Hello and welcome to video number 3. Again, just to remind you, this should not be your only study source. You should still look at your study guide and your notes. There are things that will be on the final that aren't covered in the videos. The videos don't cover everything. Okay, for this one, with a new marker this time, we're on to green. We're going to talk about energy. Energy. All right. So, energy. So we started with, we talked about a pendulum before, right? You know what I'm saying? You do. I'm talking to myself, but that's okay. Pendulum, just like this. A pendulum. There's two types of energy. There's kinetic and there's potential energy, right? There's kinetic and potential energy. So, kinetic energy, like think the Xbox Kinect, right? This is the energy of movement. The energy of movement. That's the key there. Where potential energy, which can be stored, so you can store it and kind of keep potential energy, is literally a potential to be able to move, to do work in energy terms. Okay? So if you think of our pendulum here, right? Gravitational potential energy specifically is how much energy an object can gain due to gravity. So if you just kind of think logically like that, where is the most potential energy? It's up here. This is the most potential energy because it is literally has the most potential for gravity to pull it down. So gravity wants to pull this guy down, but once it's down here already, there's nothing for it to do. So it doesn't have any kinetic energy down here. Sorry, it doesn't have any potential energy down here. No potential energy down here. A lot of potential energy up here. Kinetic energy, which is the energy of movement, right? So the pendulum, once you let it go, it swings, right? So the faster it's moving, means more kinetic energy. Faster means more kinetic energy. So here, when you let the ball go, it moves slowly, and right here it's moving fastest. So when it's moving fastest is when it has the most kinetic energy. And when it's highest in the air, it has the most gravitational potential energy. So that's the key we want to talk about there. Additionally, one thing I really want to emphasize is that energy is conserved, all right? Please, this is something you should leave here and never forget. Conservation of energy. Energy is neither created nor destroyed ever. Ever. Got it? Ever. It is always conserved. Right, Mr. Williams?
Never.
Is energy ever created or destroyed?
Nope.
Exactly. So you can think of it like if this, so our graphs again, right? We love graphs. So this is energy, right? And we're gonna have different types of energy on the x-axis here. So if you have kinetic, and then you have potential, something like this. And you have, so if you add these two bars together, this is tote. So these two bars added up equals the total. So then if the system changes to the pendulum moves or something like that, what doesn't change? The total. The total amount of energy does not change, right? It's never created or destroyed. What can happen though is it can take different forms. So maybe this time you have way more KE and only a little bit of PE, right? Just like that. But the total doesn't change. It can just take different forms like I've shown here. So that's the key takeaway we want to talk about in terms of energy. Okay. Also though, we're talking about heat. Thermal, well, let's talk about thermal energy is a better way to put it. Thermal energy. So it's the energy kind of associated with heat. So really we want to talk about heat. Heat is the transfer. So transfer, think of it like, did I spell that right? I did not. Transfer is, so you think of it like transferring, you go from one bus to another, or you transfer schools, it's the movement. So transfer, which is the movement of thermal energy. Okay, actually I should use a red Sharpie, because heat, you know what I'm saying? Yes. Three ways this can happen. 1, radiation. So radiation that has to do with light. So light sources, right? Light sources. That's radiation, like the sun. The sun is probably more yellow than that, but the sun is a source of radiation because it's a source of light. Excellent. We also have conduction. Conduction. So this is touch. So when things touch together, that's conduction, and that's heat can transfer that way. So like if I put my hand on the table, right? And heat flows from high to low, hot to cold, basically. So I'm warmer than the table is. So I'm transferring heat from my hand to the table through touch. That's conduction. And convection, right? Convection, you can kind of think of it in terms of fluids. So convection has to happen through fluids. So a fluid can, the air is actually a fluid. So the air or liquid or something like that, those, like water. So it's like when you have, so if you have the stove here, right, and you have your pot and a handle like this. So if you have water in here. So when the heat swirls around through the water, that's convection. So the swirling is convection. And the touching of the stove top to the pot is conduction, touch. Okay, so those are the big concepts of energy. Obviously conduction is touch, so a good conductor is something that moves heat very well, while an insulator does not transfer heat. You can rewind that if you didn't hear that. That is it. So that is energy. We have thermal energy, kinetic energy, and potential energy.